Lesson 7 for Year 13 Physics, and this one is on simple harmonic motion equations when the timing starts at the end position. So we're looking at displacement. When the SHM particle is at the end position, that's when displacement is a maximum, and as it comes back towards the equilibrium position, your displacement decreases to 0. So you actually end up with a cos curve. Now let's see how we arrived at this equation. So the reference particle moves from when timing starts over here to some other point over there, and in that time your SHM particles moved from the end position and coming closer to the equilibrium position. The displacement is always the distance from equilibrium. So if we look at this triangle, the length of your displacement phasor is amplitude, and if we look at this angle over here, this is y, which is a displacement, is a cos theta, or it's a cos omega t, and that's how you get this one. Looking at velocity, now velocity is 0 at the end position, and it's a maximum at equilibrium, and the velocity of the reference particle is always a tangent to the circle because it's going in circular motion. So you're looking at the velocity of the reference particle at this point and after some time over here. Now, when we convert it to a phasor, phasors always have the tail fixed at the center. So this is the phasor for when timing starts, and this is the phasor after a time t. And the velocity of your SHM particle is always the vertical component of that. So we are looking at that vertical component. So when you're looking at this angle, you actually get V is actually equal to negative a omega sine theta, or negative a omega sine omega t, and that's how you get your negative sine curve. And then the last one is acceleration when displacement is a maximum. So acceleration is always directed towards equilibrium. So when displacement, it's in the opposite direction to displacement. So over here, when your SHM particle is over here, the acceleration is this way. So drawing it as a phasor, that's how you do it. When the reference particle after a time moves here, the acceleration is directed towards the center. So converting it to a phasor, you'll get this. The acceleration after time t of the SHM particle is your component of this. So when you complete the triangle, you get acceleration is negative a omega squared cos theta, or negative a omega squared cos omega t. Why is it a omega squared? Because maximum acceleration is a omega squared. Now when you're putting it all together, this is how you get it on your formula sheet. You have 3 sets of equations for when timing starts at equilibrium, and you have 3 sets of equations when timing starts at the end position.